So I think it's time to start. So first of all, welcome to everyone. I'd like to introduce to you our next speaker, Aryan, who is the co-founder of Satelligence, a fast-growing satellite and AI company that provides turnkey solutions in biodiversity, deforestation, and carbon monitoring. Aryan was or has already gained experience in the remote sensing, consultancy, and the IT industries before joining Satelligence. In his talk, gives an overview of the current status in satellite data, AI processing capabilities, and also investigates the fallacies that come with the introduction of every new technology. Just a short hint before we start from my side. Please write your questions in the chat and I will collect them. There will be a Q&A session at the end of the talk. So now, Aaron, the stage is yours.
Thank you, Tabitha. So let's start. My name is Arjen Vrielink and I'm one of the two directors of Satelligence indeed. We are a small company from the Netherlands and we do deforestation monitoring in commodity related to commodity production, so commodity supply chains like palm oil, cocoa, soy, stuff like that, rubber, leather. And today we will have a short talk, actually not about technology at all, but actually about how people perceive or think or expectations about technology. And the theme of my talk is discussion-ready data. It's a term that I coined myself. So let's explore what that could mean, what it would mean, and what it should mean. And well, the background is a bit like how can we, with state-of-the-art remote sensing services, and in this case related to processing, AI, and machine learning, contribute to sustainability, one of the major topics in these times of climate change. And another thing on the background is that the space industry and especially satellite companies, upstream satellite companies, so companies owning satellites, but also downstream companies like us, there have been investments of hundreds of millions of dollars, but profitable exits are few and far between, and most of the companies that are still there depend heavily on defense contracts. So this is a kind of a background. So the prologue we just saw, I would first, to understand the present and to maybe say something about the future, it's always good to look back to the past, about what we thought about ourselves back then and how it turned out to be. So we're going to look back at the state of GIS, geodata in 1999. Then we have a kind of intermezzo about the jump from 0 to 1. Where does that big data, where does satellite data come in? Where is it most efficient? And then we're going to look at the state of the art right now, 2019. I know it's 2021, but 2019 is fits nicer with 1999. So I took that. And then finally, giving all those insights, how can we make the step to action towards discussion-ready data, if it actually means anything. So let's go back to 1999. This is when I went to a university. I studied in Wageningen University. I did remote sensing and tropical nature conservation. So it's quite a big stretch between the two, but I enjoyed it. And back in that time, these were the computers that you were looking at, and geodata was something completely new. And at that time, people thought, okay, now we have geodata, we have spatial information about the environment, we can finally have decision support systems. So in those days, also at the policy level, it was strongly believed that giving this new source of rich data, you didn't need to discuss any decisions anymore. The data would speak for themselves and the data would take the decision for you, the system, so to say. So that really didn't turn out to be all what they expected. So conveniently, they switched the first D to discussion support system. So I said, no, well, okay, the machines themselves won't make the decisions, but it can support the discussion. So it went from a decision support system to a discussion support system. Because, and this is my personal belief, systems and data shouldn't make decisions. Decision making should be done in the political domain. And if decision making is not done in the political domain, so you see the datafication and the algorithmification of decision making, this is what happens. So you have autonomous, for example, weapon systems that, based on data and simple logic, make decisions. I think this is a very dangerous and bad trend. So we should keep this in mind when thinking about decision support systems, big data, AI, ML, and all the ethics and morality that comes with it. So this is our baseline. This is the starting point. This is how we thought about the world 20 years ago. Now let's have a look at the role of data in machine learning algorithms within the knowledge domain, so to say. And I termed it perfectionists are nihilists, because I made a simple model of the world of the perfectionist, which looks like this. So there's 0 and there's 100, and then the perfectionist focuses on the part on the right, thinking that you got 90% filled of the world. So what do you do as a perfectionist? You focus on the remaining 10%. And I think this is a wrong model of the world, or at least I would like to challenge this model of the world, because I think the world rather looks like this. So the gap between 0 and 1 is the largest gap you can ever bridge. So going from 0 to 1 is the biggest change you can make in any system. And the remaining 10%, so the biggest gap is not between 0 and 90, in which case the remaining 10% is not interesting at all. The biggest gap is from 0 to 1. And this exactly is also the gap where satellite data, in our case, where we focus on the regions of the world, in the tropical regions where commodities are produced, where actually no data is available, this is where satellite data can make a huge difference. So basically, literally nothing is known about these systems, what is going on the ground. Basically nothing is known, and this is where satellite data can make a difference, can really add value. As opposed to, for example, if you would look at the value of satellite data in Western Europe. Western Europe is one of the most densely centered areas of the world. You don't really add a lot of information to the landscape processes, for example, in Western Europe. So we think with our company that the biggest gain is made between 0 and 1, and satellite data can make a huge difference in countries, for example, like Ghana. This is the south of Ghana in West Africa. I just put in some numbers to give you an idea about the order of magnitude of the data. So there's on the left hand, there's the raw data. Middle left is Sentinel-2, which is an optical sensor by Copernicus. Center right is Sentinel-1, which is a radar sensor. And on the right-hand side, you see a classified image where we use gradient boosted trees and random forests to create a land cover map. And order of magnitude is, let's say, from 1 to 2 terabyte to hundreds of gigabytes. And then we reduce it to maps like this, which is probably a few 100 megabytes. So mostly it's about big data is mostly, this is another misunderstanding, big data, most of the big data is useless. So you're looking for the signal in the noise. So data reduction, data removal, noise removal, and pattern detection is what you're doing all day if you're working with big data. Then what we do? So we have a lot of data sitting in the cloud somewhere. Still, we are looking for landscape features. We are looking for changes in time in the forest. Where does forest disappear? Where is illegal deforestation happening? So we do that with iterative Bayesian updating. This is just some name dropping. This is what we do. I won't go into it in detail, just to to clarify that we use an iterative probabilistic approach to detect changes in satellite data, and to make it a bit more visual, because the formulas are I think always too abstract. So this is an imaginary landscape. You can distinguish a river in the middle in blue, and then you see the red And the yellow pixels, which are yellow, is early, and the redder it gets, the later something is detected. And this is a change detection, so where is forest disappearing based on single sensor thresholding. But then with our technique, you can go to something like this, and immediately, even now to the human eye, I think you can distinguish landscape features like plantations. There are roads extracted, and you can see a lot more detail in space, but also in time. So there's a lot more information available because of the machine learning technique that we use. So that's what we do. We use multi-sensor data, huge data sets. We apply machine learning techniques like Bayesian updating to get really accurate results on the change in the landscape. Still, I would advocate this is all super interesting on the technical side and very impressive. And also, if you're into cloud engineering, it's really cool to see how to parallelize the processes. So you have thousands of computers at your cloud provider crunching all these data, and then a few hours later you have these results. But still, this picture, if I show this to clients, they think, yeah, whatever, man. What can we do with this? It's completely useless to them. So then we move forward to 2019, let's say today. And then in the GIS and remote sensing world, AI and ARD, analysis ready data, are all the new buzzwords. So from my perspective, I think the GIS, the geodata world and remote sensing world in nowadays is very data driven, very solutionist, and very focused on attributes of self. So if you look at companies that make, for example, maps like these, and we even do it ourselves as Satelligence. So this is a land cover map somewhere in Ghana with forest and cocoa plantation. So what do we advertise this with? We do it like this. This map was made with AI and machine learning techniques. And then somehow the marketing department this is what makes people buy the maps. In my opinion, it's the same as advocating and selling books like this written with Microsoft Word. It shouldn't matter what tool was used to produce the result. The result itself is what matters. Then analysis ready data. So there's this strong belief that you go from raw data to insights, and there's a ton of platforms available now, very approachable, especially if you're a student, like Google Earth Engine, the Sentinel Hub, there's the ESA, European Space Agency, with their own data cubes, which all offer analysis-ready data. And the analysis-ready data idea is that you don't have to do, the data is ready for analysis, and this fits within the from data to insights paradigm. So it would go to something like this, the pyramid data, then you go to information, you go to insights, and then you distill wisdom. Whenever someone says this, please be sure to have the bullshit alert, because I think this is totally bollocks. There is no such thing as that wisdom originates from data. You can combine data to create information, but from then on, the insights and the wisdom always happens on the human side of the equation, never from the data itself. There is no zero wisdom in data. There's no wisdom in algorithms. The wisdom and the insight is on the human side. And this is, I think, because often people forget to start with the problem. So they are data-driven solutionists and focused on attributes of self instead of thinking, what is actually the problem we are trying to solve, and who is having that problem, and even why do they have that problem? Because even if you go to wisdom without action is an empty shell. There's nothing. It's like, I have friends, but I never see them. Yeah, who cares? So wisdom without action, there's an empty shell. So if you ever see the pyramid of data, information, insights, wisdom, turn your face and move on. This is the slide to let that sink in, and for me, a sign to take a sip of water. So I will do that right now. And to calm down a bit, because otherwise I get too excited by my own words. And also a nice transition to go to the final part of the presentation. So wisdom without action is an empty shell. That means we should look at what is then the action exactly, what is actionable about the famous phrase actionable information. So I think we should move to something like discussion-ready data. So what we do at our company is actually look at how is this deforestation related to this, which is peanut butter in the supermarket. And this is, I always say, is where it happens. People don't feel comfortable anymore to buy supermarket products in which, in this case, unsustainably produced palm oil is processed. And when I was a kid, there was just one kind of peanut butter. Then a bit later in the 90s, there was a revolution in the peanut butter land. There was peanut butter and peanut butter with chunks. So you suddenly had two choices of peanut butter. If you go to the supermarket today, there are like 20 or 30 kinds of peanut butter. And it's not only the flavor stuff, there's also 10 or 15 types of sustainably produced peanut butter. Maybe even peanut butter without oil palm, peanut butter that is from sustainable plantations. And this means that there is now a change in the willingness to pay, an attitude within the consumers in the market towards sustainability. So companies can't blindly procure unsustainably produced commodities anymore to put into the products. And this gap between the supermarket and what is happening on the ground, that's the gap that our company tries to solve. So there's this list of companies, the first 500, which are like the top 500 companies related to deforestation. We target them and say, listen, we can fill the gap from 0 to 1. You don't know what's going on in your supply chain, but we can help you. And then with that information, have meaningful engagement with your upstream suppliers and stuff like that. So that would look like this. So it would be before image and after image. And then again, with our change detection, we can say, okay, there's deforestation going on here. This still, we should remember, this is still very data driven, because with the map above, maybe if you know what's going on the ground, that will be helpful. So it looks cool, it looks like a solution, but it's actually not really. So we need something else to move on, and we should start with what is actually the problem. So the problem is that people don't know what is going on in their supply chain. So the question is what is going on in my supply chain, and where is, for example, protected forest decreasing? So we developed an application which looks something like this. People go there, they see where the deforestation is happening, and then from there on, so this answers their question. From there on, they can dig deeper, get deep insights into their supply chain data, what is happening, and only then, after a few clicks, a few steps, the satellite data shows up and shows them what's going on with evidence. So what we do is we start with the problem, what is bothering the client, and from there on, we dig deeper to the data, and then use an algorithm that fits to the problem of the client, or even of the whole industry. And then the action is, this kind of platforms, these kind of insights give people, our clients, the ability to have an informed, unbiased discussion about these problems among their own company, within the sustainability department, but also with their upstream suppliers. And also nowadays, there's a lot of financial institutions who have investments in these kind of companies, who have assets in these companies, who will approach those companies, say, listen, you are a company in my portfolio, but actually the value of your company is decreasing because you're accused or involved in illegal deforestation. So please do something about it, because otherwise I will remove you from my portfolio. So these are discussions that we are looking for. And this is where remote sensing data can make a big change. And then not the big data, then the data that's filtered, analyzed, and upgraded, aggregated with AI and machine learning. And this, I think, should be the order. So you start with the problem and then move towards the data. Understand the problem if you want to use remote sensing / big data for sustainability. Always collaborate with local partners, design tailored solutions, and then only then go to the tools, so machine learning, AI, and the data. This is a final quote of my colleague, the founder of the company, Niels Wielaert. So the satellite derived information, it really works as a conversation starter. So it's the start of the discussion. It fuels the engagement process on the ground, on the phone with suppliers, with local stakeholders, in boardrooms, in investment decisions. Because in the end, it's all about human interaction. Decision making is done in the political domain and not in the data or in the technological domain. So this would be my advocacy for discussion-ready data. Put data and technology in the place where they belong to make life of humans easier, to automate repetitive tasks, but don't put decision-making in the technological or data domain. That's it. I think I'm in time, and we are ready for the Q&A now.
So thank you very much. It was very nice to listen to you, and I also could very well hear your enthusiasm for this very special topic. So we would now go over to the Q&A session, and we actually have a question from Samir, who asks, do you believe that if we can get to the explainable AI, then applying AI-produced decision would be okay?
Well, so these are two questions, and the explainable, I think what you mean is transparent and repeatable AI, because this is often a problem that it's a black box and people don't understand how the decision is made. So this is indeed a condition. We should know more about the reproducibility and transparency of AI algorithms. So that's one thing. So absolutely. The other thing is that decision making, we coin it now as one term. Decision making is not one thing. There's a whole lot of different categories of decisions. And I think there will be some decisions which will definitely be completely fine to be left over to AI. For example, the sprinkler system for your crops. So the temperature drops below, 5 degrees or goes beyond 20 degrees. The soil moisture is to this condition. And then you have some AI deciding that they will turn on the sprinklers to irrigate the crops. So that kind of decisions, I think, should be fine for AI. It gets a bit more tricky if you go, for example, if you have dikes or you have sluices where the sluices will close when high water is coming and the wind is increasing and human lives are in danger. Do you want AI then to decide if the sluices should be closed or opened? So just to give a range of types of decisions that could be made. So first half of the answer to your question, AI systems should be explainable, transparent, and repeatable. And then that will be a condition that for some kinds of decisions, I think it would be completely fine to automate that and leave that to AI.
Thank you very much. Then we have another question. I will shorten it to the second part. Do you collaborate with institutions such as ESA, the EU, or NGOs?
Yeah. So ESA is a European Space Agency. And they have a rich program of grants, funds, research programs where we actively participate. Actually, before this meeting, I was updating a application form to them. So yes, we actively participate with them and also with NGOs and the EU. In theory, the ESA is funded by the EU, so yes. And also the EU funded the Copernicus program, which is one of the biggest satellite programs in the world. So they have the Sentinel-1 and the Sentinel-2, 3, 4, 5 systems, which is super cool because what they do is all the data that is produced by that program is available for free and open source for everyone. So it's a huge, rich data set. And this is one of the main reasons companies like us can exist, because if we would have to pay for that kind of data, our value proposition, the pricing would be like an order of magnitude higher, and then we wouldn't have an economically viable product. So these kind of institutes and organizations are key to the existence of companies like us.
Okay, so now I'm looking in the chat too, because there are some more questions. I hope I pronounce the name right. It's from Naveen. Do we need to get licensed to process certain GIS data?
No. So there's two things. So one of the things, so to process data, you need two things. You need the data itself, and as I said, a lot of satellite data is just freely available, open source for everyone to use. And the second thing you need is a tool to process it, so software. And our company, for example, only uses open source software to process the data. There's excellent, like the Google library is like, if you don't use that, there's something wrong. So all the data can be processed with open source available tools. Slash, there are commercial offerings like platforms that, for example, offer a subscription fee to do maybe tree detection with AI in satellite images, or Google Earth Engine has a commercial offering. So there are commercial offerings, but if you want, you can start today with your computer, start downloading satellite images, download QGIS, and you can go ahead and start a competitor with us.
Thank you very much. The next question, it's actually from one of my colleagues. He's here under the name Tech Academy, but I know he's called Pascal. And he asks, can you tell us more about current use cases at your company?
Yeah. So our the case where we have most traction is in the palm oil sector, and this is another paradox. So they used to be the black sheep, the worst kid in the class. So palm oil is responsible for a lot of destruction, and paradoxically, usually the bad kids are the ones that adopt technology the first, because basically they have nothing to lose. So the palm oil industry is now very advanced in self-monitoring and certification. So we do have, I think, 80% of the producers in the palm oil supply chain are now clients with us. And for example, in Holland, there's the cookie manufacturer from the US called Mondelez. They make the Oreo cookies. Check the packet, the ingredients, like it's 80% palm oil. So they are also a client from us. And for them, the gap between 0 and 1 is huge. So they are in the palm oil supply chain, but they have no direct link with palm oil production. They are linked to a supplier, to a trader, and those are linked to a producer. So they want to have insights in where is deforestation happening in my supply chain. So that's super cool to see. And now we are starting to get traction in the cocoa sector, so the chocolate. In Holland, I don't know if it's known in Germany. We have the chocolate brand Tony Chocolonely, and they are now they just became a client, I think, a few months ago. And then there's like the traders, which have big names but nobody ever heard of. So these are some concrete examples that that we can mention.
I don't know how much time do you have, but there are some more questions. Is this okay for you?
I'm still good. Yeah, sure.
Okay, nice. So I have one question from Loretta, who asks, or first of all says, thank you so much for your talk. Is IA necessary to solve the problem that people don't know supply chains?
AI, to me, AI, I mean, if you do a regression in an Excel sheet, it's already AI. So AI is also a bit of a marketing term. So what you do need is computers and algorithms to do all the tedious work. So there's a lot of repetitive work and pattern matching that computers are much better at than humans, and cheaper. So that's where you need the processing power, the algorithms, and the elastic cloud infrastructure to sort all that out. And then finally you end up with, let's say, a candidate raw product. Then the human comes in and gives an opinion about the data. So that's where the human comes in, the discussion starts. But all the, let's say, all the iceberg, all the subsurface iceberg work is done by computers and AI.
Thank you. And I think it's the last question from Jonathan. What is the biggest challenge that you're facing in your business?
Yeah, that's a good question, because this is indeed what's the biggest hurdle you should overcome. And this for me, this was very like, oh, okay, I never realized that. So when you're in competition, like people think, oh, you're in competition, a business, and people think a struggle for life, maybe a boxing match, a football, like these kind of competition. But your biggest competition is people not buying your product. is if you're a new product in a new market, I mean, the world already exists for thousands of years without us. So probably it will continue to exist for thousands of years without us. So people not buying our product is the biggest competitor. So that's the biggest struggle we are, and that's why we have really long lead time. So getting people enthusiastic is easy. You get to the table, then you spend 18 months explaining why they should pay money to you for your product. So the biggest challenge is the market not adopting your product.
Okay. Then I'm just looking in the chat for one last time. But I think we're done for here. So thank you very much for this very interesting and unusual topic that you brought to us. And it was a pleasure working with you. I hope we will work together in the future, and wish all of the participants a very nice rest of the conference. It was nice to work with you.
Thank you. Also, thank you for having me and giving me the opportunity. And we will surely meet again, because the saying goes, it's a small world, but in the digital world, it's even smaller. So,
that's true.
Yeah. So,
Thank
okay.
you.
Thank you. Bye-bye.
Bye-bye.